All right. So here is a different kind of a line integral that you have. Now, if you have a line integral of this kind, where you have line integral over C, over some curve C. So this is your curves. Okay. So if you have line integral over a curve C of some function of x, y, and z, and this integral is done with respect to s. What is s? S is the arc length parameter. Now, if your x, y, and z are given in terms of the parameter t, that means x could be equal to t, y could be equal to t square, z could be equal to t plus 1. In that case, you can rewrite this integral in terms of t. So finally, when you rewriting the integral in terms of t, x, y, and z will change in terms of t, and ds will also change in terms of dt. So that's what we see in this case. Okay. So you look over here, you have this line integral which is done with respect to s. All right. X, y, and z are written in terms of x of t, y of t, z of t. That means you've written x in terms of t. And your ds, what does ds become? ds becomes square root of x dash of t the whole square plus y dash of t the whole square plus z dash of t the whole square dt. Okay, so that's basically what you get. Now, usually speaking, s is the integral of square root of x dash of t the whole square plus y dash of t the whole square plus z dash of t the whole square with respect to t. When I take the derivative with respect to derivative of s, sorry, when I take the derivative of s with respect to t, I'm only left with the square root sign. So ds becomes the square root multiplied by dt. That's what you see here. Okay. So now if I look at a problem, now look at this problem here. You have line integral of x square z ds. So the integration is done with respect to the parameter s. So the next thing you will want to check is x and z given in terms of t? Yes. X is cos t and z is sin t. And similarly, they've given you y equal to 2t, but you will not require y here for x square z. You'll only require it for ds. Okay? So what happens is x square z ds becomes integral x square becomes cos square t because x is cos t. Z becomes sine of t. And out here, ds, if you've noticed, I've written it as square root of 5 dt. Why is that? Because ds will become derivative of x with respect to t, that is minus sine t the whole square, plus derivative of y with respect to the t the whole square will become 4, plus derivative of z with respect to t the whole square will become cos of t the whole square. And there's a dt outside the square root sign. So sine square plus cos square is 1. 1 plus 4 will give me 5. Alright? And now my integration is going to be done with respect to the parameter t. So if I'm integrating with respect to t, what are the limits of t? They've told you that t goes from 0 to pi. And this is how you solve the integration and get the answer.